welcome to the deep dive. Today, we're jumping into some source material that explores a truly ambitious idea, the quest for a single universal learning algorithm.
That's right.
Our sources for this deep dive are excerpts, summaries, quotes, and Q&A from Pedro Domingos' book, The Master Algorithm.
And our mission today is really to unpack this core concept, what the master algorithm is, why people are pursuing it, the different approaches in machine learning it tries to bring together, and importantly, the potential impacts and the critical questions this whole quest raises for the future of AI and really society.
Let's dive right in because the premise itself is pretty mind-bending. The idea isn't just building another powerful AI.
No, it's much bigger than that.
It's the pursuit of one algorithm, one capable of learning anything from any data, basically solving any problem. There's a quote from the book that says, "The master algorithm could be the key to unlocking new levels of intelligence, creativity, and productivity in every field."
It's an extraordinary vision, definitely. And it's, I think, essential to understand right from the start that the master algorithm isn't like a piece of code sitting on a server somewhere right now.
Right, it doesn't exist yet.
Not as a finished thing, no.
Yeah.
It's the ultimate goal, maybe the theoretical North Star for a big part of the machine learning community. It's the quest for that single, unified algorithm that could, in theory, derive essentially all computable knowledge directly from data.
Okay, so it's less about a specific tool we have now and more about the grand scientific challenge of the whole field, kind of like finding the fundamental principles of learning itself.
Exactly. That's a good way to put it. The ambition is to integrate all the quite different methods we have for machine learning today. And by doing that, automate the actual process of learning.
Automate learning itself.
Yeah, think of it as building machines that don't just follow instructions based on data, but that actively learn from experience, adapting, improving dynamically. Much more like how biological intelligence seems to work.
And this is, well, it's a huge departure from traditional algorithms, isn't it? They're usually built for very specific tasks.
Completely different. A traditional algorithm, you give it explicit, predefined rules to do one job, sort numbers, calculate something specific, process a database query.
Right.
The master algorithm idea suggests we could have one core mechanism that doesn't need hand-coded rules for every single scenario. It would learn the necessary rules or patterns itself from raw information and be applicable across vastly different areas.
Okay, so it's kind of the AI equivalent of finding the unified field theory in physics, maybe?
That's a common analogy, yeah.
The book breaks down the current landscape of machine learning into, well, fundamental building blocks and also, interestingly, into different tribes or schools of thought. Maybe let's start with the foundational types of learning problems the field tackles first.
Right. Good idea. Well, the ultimate goal is unification. Machine learning today works on different kinds of problems, and you're probably familiar with some of these already. There's supervised learning. That's where the algorithm learns from labeled examples. You give it data and the correct output, like pictures of cats and dogs with labels saying cat or dog, and it learns to classify new ones.
Okay, learning from examples with the answers provided. Got it.
Then there's unsupervised learning. Here, the data comes without any labels. The algorithm has to find structure or patterns on its own.
Like finding hidden groups.
Exactly. Grouping similar news articles, finding clusters of customers, maybe identifying unusual patterns that could indicate fraud, that sort of thing.
So finding patterns without being told what to look for.
Precisely. And then there's reinforcement learning. This one is all about learning through interaction and feedback.
Trial and error.
Kind of, yeah. An algorithm takes actions in some environment, gets rewards or penalties, and learns over time to make sequences of decisions that maximize its total reward. Like training a robot to walk, or an AI to play a complex game like Go.
Learning by doing, basically. Okay, these really do seem like fundamentally different ways to approach learning.
They are.
Which brings us nicely to Domingos' idea of framing the field into these 5 distinct tribes.
Yeah, this is where the book gets really fascinating, I think. It looks at the different philosophies, or you could say worldviews within machine learning. Domingos argues the field isn't just one thing, it's divided into these 5 major schools, and each one has a pretty distinct belief system about how intelligence works and how machines should learn.
5 different angles on the core problem. So who are these tribes?
Okay, first you've got the Symbolists. Their core belief is that intelligence boils down to manipulating symbols and logic.
Like rules.
Exactly. They focus on rules, Reasoning, formal knowledge representation. They build models that look a bit like old-school expert systems using if-then statements, deduction, that kind of thing.
The world as a set of logical rules. Okay, makes sense. Tribe number 2.
Then come the Connectionists. Their worldview is very much inspired by the brain, the idea that intelligence emerges from these big interconnected networks of simple units, artificial neurons.
Neural networks, deep learning territory.
That's right. They excel at pattern recognition images, speech, often using deep learning.
Intelligence from network structures. Got it. Next.
Next up, the Evolutionaries. They believe learning can basically be achieved by mimicking natural selection.
Survival of the fittest for algorithms.
Pretty much. They use algorithms that evolve solutions over generations through processes like mutation, reproduction, selection, often used for tricky optimization problems where the solution space is huge.
Interesting. Okay, who's fourth?
The Bayesians. They see everything through the lens of probability. Their core idea is that all knowledge is fundamentally probabilistic belief. Learning is about updating these beliefs as you get new evidence, using Bayes' theorem.
Okay.
They're really powerful for dealing with uncertainty and making inferences, think spam filtering or a medical diagnosis.
All about probabilities and updating what you believe based on data? Makes sense. And the last one?
And finally, the Analogizers. They believe learning happens by recognizing similarity, transferring knowledge from past experiences to new situations.
Learning by comparison.
Essentially, yes. Techniques like instance-based learning or kernel methods fit here. You solve new problems by comparing them to similar cases you've already seen, like how recommendation systems suggest movies based on others you liked.
Right, okay. So we've got logic-based systems, brain-inspired networks, evolutionary processes, probability models, and similarity-based methods. Wow, 5 profoundly different lenses on how a machine could learn.
Exactly. And Domingos' central argument, maybe his most provocative one, is that the master algorithm won't come from just one of these tribes winning out in the end.
Ah, okay. So it's not a competition where one philosophy takes all.
His argument is no. It will arise from successfully integrating the core insights and the strengths of all these different schools of thought.
Bringing all the different philosophies together somehow. So it's not just having like a toolbox with 5 different kinds of hammers.
Right.
It's about building something fundamentally new by combining the principles behind all 5 tools.
That's the core challenge. It's not simply mashing them together. It's about reconciling these quite different worldviews on what learning is. The source uses an analogy, like a math student. You don't just learn addition or just calculus. You need to integrate different mathematical tools to solve complex problems, right?
Yeah. Oh, okay.
Or think about that hospital AI example. You might need systems that can analyze statistical data, maybe something Bayesian or Symbolist, recognize patterns in scans, which is very connectionist,
Right.
and maybe learn optimal treatment strategies through trial and error, which sounds like reinforcement learning. A truly intelligent system would likely need all these modes working together seamlessly.
And this ambition, this drive to build a truly unified learner, it really feels like it mirrors the way humans learn too, doesn't it? We don't just stick to one method. We use logic sometimes, we recognize patterns, we learn from feedback, we draw analogies.
It really does. It brings up some deep questions about what intelligence fundamentally is. You know, the book even suggests every human being is a machine learning algorithm, and that's what makes us human.
Wow.
So the quest for the master algorithm is, in a way, maybe an attempt to reverse engineer that integrated human ability to learn.
Okay, so beyond the pure scientific curiosity, let's talk impact. Why does this quest matter to you, the listener? What's the real-world payoff if such a breakthrough ever happened?
Well, the potential impact is, frankly, it's transformative. It could touch virtually every aspect of life.
Like what? Give us some examples.
Okay, imagine healthcare. Truly personalized treatment plans, generated by analyzing just vast amounts of patient data, leading to much earlier diagnoses, more effective therapies tailored to the individual.
Or finance market prediction, risk assessment reaching unprecedented levels of accuracy, maybe.
Absolutely. And think about your daily life. Truly intuitive personal assistants that actually anticipate your needs, optimize your schedule, manage your smart home, vastly more efficient, transportation, logistics, personalized education systems that adapt to your specific learning style, even tools that could enhance human creativity or streamline really complex scientific research.
It's huge potential.
It really is. There's some great quotes in the source material that capture this scale, like, machine learning is the new electricity.
Powerful analogy.
Or data is the new oil, and the algorithms are the refineries.
those analogies make it pretty clear this isn't just about, incremental improvements. It sounds like it's about fundamentally changing how we interact with technology and unlocking potential we haven't tapped yet.
It is, but, and this is really important, it's vital to balance that huge potential with the critical perspective that the sources also provide. This quest isn't without massive challenges and some really crucial questions.
Right, this isn't just a smooth, guaranteed path to some AI utopia. What are the main hurdles that are discussed?
Well, one fundamental question is just feasibility. Can one single algorithm really handle the sheer complexity and the diversity of all possible learning problems out there?
Good question.
Critics raise some very valid points.
Yeah.
Maybe different problems are just fundamentally so distinct that they require specialized solutions. Maybe the idea of a single master algorithm is an oversimplification, or perhaps even impossible.
So maybe the universe of problems is just too varied for one master key. That's a possibility.
That's certainly one perspective.
Yeah.
And then there are these significant technical challenges. Just handling the sheer scale and diversity of data you'd need,
Yeah.
making sure the algorithm is actually computationally feasible, that we can run it, and figuring out how you truly integrate these 5 very different, sometimes conflicting approaches at a really fundamental level. These are monumental technical hurdles.
The technical mountain to climb sounds immense.
It really is. And tied very closely to the technical side are profound societal questions raised by having something potentially this powerful.
Like ensuring this power is actually used wisely.
Exactly. The source material really pushes us to consider things like ensuring fairness, mitigating algorithmic bias.
Which is a huge issue already.
A huge issue. The risk that algorithms trained on biased data just perpetuate or even amplify existing societal inequalities is very real. Then there's the challenge of transparency, understanding why a complex system made a particular decision. That's crucial for trust and accountability, especially in critical areas like medicine or finance.
And knowing the why behind the decision?
Absolutely. And of course, the potential for misuse, everything from pervasive surveillance to manipulation, and the very real economic impacts, like job displacement, that we need to think about.
Yeah, these aren't just side issues, are they? They seem central to the responsible pursuit of this kind of technology.
Precisely. They demand careful deliberation and, likely, new guidelines as we move forward. The book also emphasizes that the path forward needs more than just computer science.
Right. It's not a solo mission for one field.
No, absolutely not. A true master algorithm, if it's even achievable, would almost certainly require deep insights and collaboration from fields like neuroscience. How does the brain actually learn? Psychology. How do humans reason and make decisions? Statistics and the mathematical bedrock of learning. And crucially, philosophy and ethics. What should we build and why? It's a profoundly interdisciplinary undertaking.
That makes a lot of sense. You need to understand learning from every possible angle. And for us, the listeners, just understanding these big ideas that empowers us.
Absolutely.
Yeah.
I really believe that. In a world that's increasingly shaped by algorithms, understanding the foundational concepts of machine learning, the different ways machines learn, these major schools of thought, the potential and the pitfalls, it's becoming crucial.
How so?
Well, it helps you critically assess the technology you interact with every day. It helps you navigate the job market in a future that's going to be even more tech-centric. And it lets you participate meaningfully in the important conversations about where AI is heading and how we want it to shape our world.
So it's about being informed participants in this future, not just, passive observers.
Exactly right. It's about recognizing that this whole quest for the master algorithm isn't just some technical puzzle for researchers to solve. It's really a fundamental inquiry into the nature of intelligence itself.
Wow. Okay, so summing up this deep dive then. We've explored this really audacious quest for a single, universal master algorithm, as Pedro Domingos lays it out in his book. We've broken down the different types of learning problems: supervised, unsupervised, reinforcement learning, and the 5 distinct philosophies or tribes that currently approach them: the Symbolists, Connectionists, Evolutionaries, Bayesians, and Analogizers.
And we've dug into the book's central idea that the path forward probably involves integrating the strengths of all these different approaches rather than just one winning out.
Yeah.
We've also touched on the truly breathtaking potential this holds for, well, almost every field and aspect of life.
And crucially, we've also highlighted the immense technical and societal challenges this quest faces. Everything from the fundamental feasibility of unifying such diverse approaches to the critical need for really thoughtful consideration regarding fairness, transparency, and the potential for misuse.
Right. Understanding these core concepts really does empower you, the listener, to engage with the future that machine learning is building.
Absolutely.
And it leaves us with some pretty powerful questions to think about, doesn't it?
Yeah.
Perhaps the most profound one, hinted at in the book, is if we ever do achieve a master algorithm, something capable of learning from everything and potentially knowing us intimately through our data, will it help us decide not just what to do, but ultimately maybe even who to be?
That's a deep thought. Or perhaps, looking at all those challenges and ethical questions, most important question isn't really can we build it, but how do we ensure that the pursuit and the potential achievement of such immense power truly benefits humanity as a whole and not just a select few? It's definitely something to keep thinking about long after this discussion ends.